Hey everyone, um, welcome back. We're doing identities. This is really our last lesson on just identities, and then lesson 8 will be equations with identities. It might sound a little scratchy on this video because I'm using just the internal mic, so my apologies. Okay, so for today we're looking at double angle identities, and these ones are the sum and difference identities that we've already covered. Below that, they develop the double angle identities. In other words, where did they come from? So if you were interested in that, probably you would want to work through a few of those. It's not something I'm going to quiz you on, but if you wanted to work through those, you could, to prove each one of those identities. But what we're going to do is we're going to use those identities, okay, that the cos of 2a is cosine squared minus sine squared a, and tan 2a is 2 tan a minus tan squared a. Okay, so we're going to use all of these double angle identities, which are on your formula sheet, and we're going to use them in other proofs. So let's take a look at example 1. Okay, prove that the identity 2 tan x over 1 plus tan squared x, oh, I guess we are kind of proving this one then, is equal to sine 2x is valid and state the non-permissible values. Okay, so why don't we actually start with the non-permissible values? That's kind of the more difficult part. So there's our obvious restrictions, as in 1 plus tan squared x cannot equal 0, and we'll have to solve that. Then there's a sort of a sneaky restriction with tan, because tan is sine over cos, right? So therefore cos can't equal 0. We'll write that one down as well. So cos x can't equal 0. All right, let's solve for this tan squared one. Okay, so we subtract 1 to the other side, then we get rid of the square by square rooting both sides. Oh, and we're square rooting -1. We cannot do that. So this one gives us no non-permissible values for that one. However, for cos x equals 0, cos would be 0 there and there. So at pi over 2 plus n pi, and those are values where n is an element of the integers. Those are values that x cannot equal. Okay, so there's our non-permissible right here, NPVs. Okay, let's prove this identity. All right, okay. So how about we work on the left-hand side? It looks more complicated. So let's first of all start off by replacing tan x on top with sine over cos. Okay, and on the bottom, 1 plus tan squared, that sounds familiar. That, I think, on your formula sheet is secant squared x. Okay, so let's go with that. So we replace the squared identity. This here is equal to secant squared, and we replace the top tan x with sine over cos. All right, next step, secant squared could be replaced with 1 over cos squared. So we're going to do that. 1 over cos squared x. Now we're dividing by a fraction, so we could multiply by the reciprocal. So that would become 2 sine x over cos x times the reciprocal cos squared x over 1. There we go. And now we have a common factor that we can get rid of. Squared goes here, one of the cos's go there, and we're left with 2 sine x cos x. Hey, that's an identity, right? Let's look at our formula sheet, or we can work on the right hand side, but that is equivalent to the sine of twice the angle. And there we go. All right, so we've shown that sine 2x is equal to 2 tan x plus 1 plus tan squared x. Oh, I was thinking that was this identity. It's not. What's different between those two? That. It's a minus sign, not a plus sign. Okay. So, oh, sorry, I don't know if you were as confused as I was there for a moment. I was thinking that it was this identity, the tan double angle one, and I'm thinking, that doesn't sound right. Tan twice the angle equals sine twice the angle? No. Okay, I digress. Let's go on to example number 2. Use the identity, sine 2a equals 2 sine a cos a, with a replaced with 3x to determine a double angle for sine 6x. Okay. So they're saying, let's take this and go 2 sine 3x cos 3x and they basically want to know what this would equal. Well, if you compare, now instead of a, we have 3x. So instead of a on the left-hand side, we're going to sub that out and put in 3x. So in other words, sine 6x is equal to 2 sine 3x cos 3x. Okay, so let's look at writing double angles identities for cos 10a. Okay, so we know that cos 2a is equal to, well, there's a few we could use here, but let's say we use kind of the first one, cos squared a minus sine squared a. Okay, so instead of a, I hate that they use the same variable, but if we compare this to this hand side, so 2, and then that would have to make this a 5a, right? See how that could be equivalent? Okay, so then replacing that on the right hand side in this identity, we would scoop out the a and put in what our new a is, which was 5a, and then minus sine squared, and the same thing, 5a. Okay, let's take a look at that. It can be a little confusing, so let's just talk about that. Hey, sorry about that, I'm back. Okay, so yes, okay, so we were basically trying to write cos 10a, and we were comparing it to what we had for a double angle with cos 2a from our formula sheet. So if you'll notice, instead of 2a, we've got 10a. So you could think of that as having basically 2 times 5a. Okay, and then this 5a would basically replace in the identity a on the right-hand side. So there we go, 5a in each one. I know it can be a little tricky, especially why did they have to use a, right? Okay, let's look at tan x. Ooh, tan x. Okay, so what's our identity for tan 2x? Let's write that down. Tan 2x from your formula sheet is equal to 2 tan a over 1 minus 2 tan squared a. So tan 2a, double the angle, is equal to 2 tan a, single angle, minus 1 minus tan squared a on the bottom. Okay, so let's compare this. We basically, this is our tan 2a. So instead of 2a, we've got x, right? So if we have x instead of this, let me do that in a different color. This is basically x. Then this over here has to be half of that. See, 2a versus a? So that would mean to get to here, we'd have to use half an x. Okay? Or going the other way, whatever's here, this on the left-hand side is twice the angle. Okay? So what we're going to do is in our equation, we're going to have 2 tan, and instead of a, we would be using half of our angle x. Okay? So this is how the double angles work. 1 minus tan squared, and again, half x. You could use brackets on that. All right, so take a look. What's inside here is double whatever is inside here using that identity. All right, I know these are a little weird, but let's try example 3. Express each of the following in terms of a single trig function. Okay, so first of all, when you look at this, you have to recognize what it's most similar to. And this is most similar to the fact that it is sine 2a equals sine a, 2 sine a cos a. Okay, so really what we're saying here is instead of a, we've got 4x. So instead of a in our original identity, we're going to put in 4x. So this would be equivalent to the sine of, using what this is equal to here, 2, and then in for a goes 4x. And just simplifying that a little bit, that would equal the sine of ax. Okay, let's look at b. Okay, so circle your angle, what's in there, and then see if you can figure out which identity on your formula sheet this is similar to. We have cos squared minus sine squared. Okay, so on your identity sheet, that is basically cos 2a equals cos squared a, I hate that it's a, minus sine squared a. Okay, so for us, instead of a here, we have 1/2 a. So instead of a on the left-hand side, that's going to be cos of 2. Instead of a, we have 1/2 a. Now just simplifying that a little bit, 2 times 1/2 is just going to be 1, so this would turn into the cos of A, would be our final answer. Okay? All right, last question. Sine 5/2 x, cos 5/2 x. Okay, let's put a little box around those angles, so try and see those as A's. Okay, so sine A cos A. We don't exactly have that on our formula sheet. What we have is sine 2A equals 2 sine A cos A. If we were to divide both sides by 2, like that, we would have 1/2 sine 2A. Can't divide inside there. I don't know what I just wrote there. Can't divide inside the trig function. You have to leave that alone. But this is sort of like 1 over 2 then. Sine, because there's a 1 in front of the sign that we don't write, but is there, would equal sine A cos A. So manipulating that identity a little bit, this is what we get. 1/2 sine 2A is basically equal to sine A cos A. So instead of A, we have 5/2 x. So instead of A on the left-hand side, we would sub in 5/2 x. Okay, and just simplifying that a little bit, we'd have 1/2 sine, the 2's would cancel, and we'd have 5x. And there we go. So, double angle identities. Okay, if you're trying to manipulate them like we did on the last 2 examples, just try and spot which one it's similar to, and then if you put a little box around the angles, and just remember that is basically, if it's the right-hand side, that's going to be half of what's on the left-hand side for an angle, and if it's going the other way, like example 2, this is basically double whatever the angle is over here on the right-hand side, using the identity. Okay, so you'll never know until you put this to work on the assignment, so give it a try in class tomorrow, and hopefully it goes well. I'll see you again for our last lesson, lesson 8, where we return to solving equations with identities. Okay, see you then. Thanks for listening.